Well, hello there. Couldn't even talk. Hello there to my Cal State Straub molds. We're on the last lesson of chapter 10. Woohoo! Last one I got a videotape this week. Just went out for a nice walk for a 1.25 mile walk. So ready to go for one more notes thing today. Okay. We're going to start off with this warm up that you see in front of you. I want you to look at the problem. It says a student collects an SRS of 50 audience members that attended a steel drum concert. If only we could be having those right now. And performs a 90% confidence interval on the true proportion of audience members that waited in line for more than 20 minutes and came up with that CI. So please explain what is meant by a 90% confidence level. Not the interval. This is not a we are thing. This is what does the 90% confidence level mean in context here? And then B, someone was heard saying, I think over 75% of us had to wait outside for over 20 minutes. What would you think about their claim based on the CI? When you're done with that, do number 2. An independent random sample of 100 San Diegans was taken from a normal population. So you already know the population is normal, but anyhow. They were asked, are you taking someone out to dinner for Valentine's Day? 46 out of the 100 said yes. So now you're going to perform a 99% CI on the true proportion of San Diegans taking someone out to dinner. Okay, so that means now you're going to do state, plan, do, conclude, and I talked to you guys about making sure you have a sketch. So that thumb remind, so you use your hand, state, plan, do, conclude, sketch. Okay, and then I'll come back and see how you did. So now that we're back, let's go over the answers to this. Okay, explain what is meant by a 90% confidence level. Remember, this means that in the long run or over many times, 90 out of 100 samples taken that way of this size, 50, okay, from this population will contain the true proportion. Okay, that's what a 90% CI level means. Okay, but then what about that person who said 75% or more waited? Because 75% is not in this confidence interval. The highest is 59%. It is unlikely that over 75% of the people waited more than 20 minutes. Now, our interval could be wrong because we only did a 90% CI. So 10% of the time there would be an interval that did not capture the true parameter. However, this is way out of there. So I would imagine it's very unlikely that that's true. So that's quite the exaggeration that person had. Hopefully that's what you came up with. All right, your state should be that we're performing this last sentence here, a 99% confidence interval on the true proportion of San Diegans taking someone out to dinner for Valentine's Day. Notice you've got to have your parameter in there as well as your population. So make sure those two, parameter, population, are in your states for sure in the context. As I stated in our notes from yesterday, I always put out my information. So N's 100, P hat is 46 out of 100. So that's my P hat right there, the point, there we go, 0.46. Our C level is 99. So that goes along with a Z star of 2.576 because I remember that proportions always use Z star. Okay, state. Let's go to plan. SRS was given. You checked your normal conditions, and both NP and N times 1 minus P would be greater than 10. And there are certainly more than 1,000 San Diegans. So we have independence. So all three, notice how I check, show that they all work. So the do, there's my confidence interval, the work with the formula, filling in my P hat and my Z star, and then the 1 minus P hat over here, coming up with an interval from 0.332 to 0.589. So then our conclusion will be, we are 99% confident that the true proportion of San Diegans taking someone out to dinner Valentine's Day is between 33.2%. Remember to change your decimal to percents in your conclusion, right? And 58.9%. Our sketch here shows, though, the decimals. That's what you'll put in your sketch. The p hat goes in the middle, just like when we did means, the x bar was in the middle, and then you had your confidence interval boundaries on the each end. It's exactly the same thing here. Your confidence interval boundaries, your p hat, that sample proportion in the middle, and then shading showing that that's 99%. Woohoo. All right. Before we go to the actual notes, I'm going to go back to your worksheet. Hopefully you have printed out this worksheet and have it in front of you to do. If not, you could do this work on a separate paper right now, because these are two problems. They're not too difficult to just do on separate paper. But if you need to pause me and go get print out so that you can have it for your records, then please do so now. Okay, here's what I'd like you to do. Next is to construct and interpret a 95, I believe it is, percent. My eyes are a little crazy right now. Yeah, confidence interval for the true proportion of red beads in a thermos. Okay, so the thermos is going to contain 3,000 beads. Okay, the class took an SRS from this thermos and got 251 beads out. So that's the sample size N, resulting in 107 red beads and 144 white beads. All right, so the population is 3,000 beads. The sample size N is 251, and then our p hat will be that 107. Are we doing it for red? Yeah, 107 out of 251. So do your state plan, do conclude sketch on that, and then I'll post up the answers after you do a little ed puzzle for me. All right. Let's come back to this. There we go. Let's check your work. State, we want to estimate the true proportion of red beads in this thermos. So remember before I've talked to you about how AP Stats likes to see the process you're doing, procedure that you're going to implement. And this is a one sample Z interval for proportions. I haven't mentioned that to you before, so you might want to jot that down. That's how this one would be called. It's one sample data. And we're doing a Z interval because it's proportions. We use Z. And then you note that you're doing it for proportions, because remember, we could do a Z interval for means if we know sigma. So this is a Z interval for proportions. Okay? And construct a 95% CI. It is a one sample Z for P if our conditions are met. So let's go to our plan and look at the conditions. Random was given. Independent, if you times N times 10, you'll have less than 3,000, the population, so we're good. N P hat and N times 1 minus P hat are both greater than 10. So hopefully you got your conditions checked. Now the do, there's a formula in case you did an incorrect formula, double check that and then see how I plugged in P hat. The Z star for 95 is 1.96. And then here's your P hat and 1 minus P hat. I don't know why I keep losing my little arrow here. There it is. P hat and 1 minus P hat divided by N, square rooted, and you get this confidence interval. So then your conclusion is we are 95% confident that the interval from here to here captures the true proportion of red beads in the thermos. A better way to say that really would be that you are 95% confident that the true proportion of red beads in this thermos is between 36.5% and 48.7%. So then you'll see at the bottom, I've created my sketch, and in the very center, you'll find the P hat, 0.426, and then on either side goes the rest of the interval from the endpoints of it, and then I've written 95% in the middle. Now, one thing I'm showing you how to also add in here is you need to know what your standard deviation is. And that's this piece, right here that you're timesing by the Z star. Where did my arrow go? There we go. Right here in the bottom left-hand corner, I showed you that if you took that data right there, you get 0.03. So as you mark off 0.03, 0.03, right into here, you'll see your standard deviation of this distribution is 0.03. So that's an additional piece now that we can be adding to our CI sketches, trying to build it up. This is the last lesson. So I think you know how to find on the means. You just do the S divided by square root of n or sigma divided by square root of n, and that would be your standard deviation on your sketch. Okay. All right. So done the warm-up, we will come back to this worksheet, to page 2 after the notes. So let's go to notes and take a look at the remainder of, oops, let's see, I can't get this to go. There we go. All right, as my dog laps up water and my clock goes off. So we all have things going on in our homes, don't we? Okay. What we talked about in the previous notes was just how to create that CI for proportions. Now what we need to do is figure out, well, how do I find the sample size if I'm given a certain margin of error, just like we did for means, but let's do it for proportions. So this hopefully will go quickly because we've done this for means. Let's try it for proportions. So your margin of error for proportions is this standard deviation formula here, estimating with p hat times your z star. Okay. The proportions have things a little bit differently in that sometimes they're not going to give you a sample proportion. This is a very interesting situation. And so sometimes we're going to have to guess at what p hat is. We're going to have to look at the population and make an estimate. And so this is called p star. We got another star here. We have Z star, T star, now P star, when we are needing to guess at the P hat, okay? So we're gonna do one of a couple of things. Either we use past experience or a past study of something similar and use that proportion to guess as P star, or this is the main thing that will pop up most of the time in AP Stats. What they have you do is if no proportion is given, if it doesn't say 44 out of 100, then you have to use P star to be 0.5. 0.5 will give you the most conservative estimate of a sample size. It'll give you the biggest sample size you would have to take if the bigger this P hat is here to point, or closer to 0.5 it is here, the larger this fraction here becomes. Okay, so if P hat is not really 0.5, we've just done the most conservative estimate that we possibly could. So really, we're going to be okay. All right. So if P hat's not known, you go to this formula, and we're instead going to put P stars in here. Now, if P hat's known, you use your P hat. But if the problem doesn't give you one, then you put P star in there. And it just says if you expect it, like if you're looking at data and it's expected to be between 0.3 and 0.7, then go ahead and use 0.5. But if you expect it to be closer to 0 or 1, using a 0.5 will just give a margin, give you not a margin too large. It's actually going to give you a sample size way too large than what you need. That should say N there, not M. Okay, so let's do a problem. See what you got there. Okay. A national opinion poll, 44% of U.S. adults. So now they told us the P hat, didn't they? They gave us the sample from a poll. This is not all the people in the nation. It's just from an opinion poll. So this is your P hat. They agreed that educational vouchers were a good idea. If we were in class, we'd have a little bit of discussion about what an educational voucher is. But some people promote, and some states do have a situation where people can get the amount of money for you for your schooling, and your parents can then take that voucher to any school you choose to go to, private or public. and use that money towards it. There's a lot of political debate over that and what that would do to public education. And so that has not become a widespread idea, but that has been out there often on election political ideas. Okay. The new Secretary of Education under Donald Trump is in favor of vouchers. So that's where that has been coming up lately too. All right. So how large of a sample size should we obtain if we want to keep a margin of error in this to be 0.03? So that's 3%, right? We want to be within 3% of the truth. How many people should we sample? This happens all the time in pollsters and in statisticians. You've got to know how many people should I sample if I want to have valid results and stay within a window of the truth. So 0.03 is 3% or better. That means smaller than that. So we want to be within 3% with 95% confidence. Okay? So to get going on this, you're going to fill in that little formula here. This is your margin of error, right? Z star for 95 is 1.96. P star right here, we know P hat, so we're putting it in, dividing by N. All right, and now the math is just to finish this off and solve for N. A little different than we did for means. In this case, first what I did was divided both sides by the 1.96, and that gave me this 0.015 here. This time, since everything is underneath the square root, we need to square both sides first. Last time we cross multiplied, then squared. Now what we got to do is square first, and then we'll cross multiply. Okay, so then when you square both sides, this is what you get over here on the right. Okay. And then you cross multiply and get that 0.002n is greater than or equal to this 0.2464. Divide that by 0.002 and you get 1051.74. Just like we did with means, this you need to take the first integer greater than this. So we will then say our sample size needs to be at least 1,052 people. Okay. So let that sink in a little bit. Hopefully that's something that you're understanding. It's exactly like we did for means, just the different formula. Okay. But now the next problem, look at this one. Politician wants to create a 95% CI for his campaign with less than 0.02 margin of error, 2% margin of error. Notice when we did means, it was giving us numbers, right? This is a percentage, so we're getting this decimal point. How many people will he have to ask the question, are you voting Republican or Democrat? When I look at that, I don't see a P hat. Straw, it doesn't say anything. What am I supposed to do? Well, this is one of those cases. Is it likely that voting Republican and Democrat would be between that 0.3 and that 0.7? Well, typically it's around a 50-50. And of course, it's not exactly like that. But yeah, voting Republican or Democrat is likely to be between that 0.3 and that 0.7. So we're going to let P star be 0.5, that conservative estimate for us. So I just wrote here, we don't know P hat, so we're going to use 0.5 because we assume that P hat will be between that 0.3 and 0.7. So we go to that same margin of error formula. It's a 95% CI, so I put my Z star for 95 here, 0.5 divided by N, and that's less than or equal to our 0.2 margin of error. So I divided both sides by 1.96, and then we're going to square both sides. And when we do, we get this right here, cross multiply and solve for N. So I cross multiplied and divide by that 0.000104. And I happen to get exactly 2401. So there's no decimal point here. So you would tell that politician, for this campaign, he needs to go out and at least talk to 2,401 people. Okay. All right, one more. This time, this is on you. I'm going to have you do this and stop with Edpuzzle for you to tell me how you did. You have a great cookie recipe, but sometimes they fall apart. So how many cookies would you need to bake to ensure a margin of error of 0.05 or less with a 98% CI. Set that up and see how you do, and we'll come back and take a look. Again, there was no proportion given, so make sure you've used P star is 0.5. All right, if you've had your time to get work on it, here is the formula set up and the math to solve it. So you should have come up with at least 542 cookies. Have fun baking to get all those cookies ready. But that's how many you'd have to make to be within a 5%. Either way, margin error there. Of those cookies falling apart. Okay. Now, one thing that's really nice is your calculator will do this proportion interval for you. So let's go to stats, tests, and find the one prop Z interval. So remember how we talked earlier about when you're making your doing your CIs on the tests or quizzes, you need to state what procedure you're doing. Well, this is also helpful if you're going to go use your calculator. You're going to tell the reader that you're using a one prop Z interval. And all you have to do is enter the X and the N. If they give you the 44 out of 100, you would put 44 and 100 there. So go to your P hat, and that's where you'll find X is on top and N is on the bottom, right? You enter X and N, okay? And enter the confidence level, whatever it is, 95, 99, and then hit calculate. How nice is this? And it'll give you your confidence interval for P, and it'll tell you what P hat is and what N is. Straight away, boom, done. So if you use that instead of doing all the math for finding the confidence interval for a proportion, you just need to note this. You need to note the procedure, and you need to note what you entered. You have to put X equals N equals your C level, and then you put your interval down. And of course, you'll have to write your confidence interval, your conclusion of the confidence interval in context. Okay, one last thing to do is to go back to that worksheet. On the back of your worksheet, there is a second problem now that I want you to do, and it's to find N, like we just were practicing in the notes. So suppose that you wanted to estimate P, which is the proportion of students at a large university that have a tattoo. And you want to do that with a 90% confidence and a margin of error of no more than 0.05, so 5% margin error. So determine how many students should be surveyed. Take the time to do that. Put your answer in Edpuzzle, and then we'll come back and check. All right, if you had time to check, it should get it done. Here's time to check. So again, we look at this and we say, oh man, he didn't give me a P hat. So because I didn't get a P hat, I'm going to use 0.5 as P hat to be my conservative estimate. A 90%, 99% CI, yes, has a 1.6, no, it's 90%, sorry about that, has a 1.645 Z star. So here's my formula for the margin of error using the Z star and the 0.5. And I need it to be less than or equal to that 0.05, that largest margin of error that we can have. And I did the math here of dividing by 1.645, squaring both sides, multiplying, cross multiplying this N times this to be 0.25, and then finally dividing 0.25 by this lovely decimal. And you get greater than or equal to 270.6. The first integer beyond that would be 271. So your answer should be that you need to survey at least 271 students. Very practical questions, guys. Hopefully this makes sense. Over the next couple of days, as we get ready for the test, be sure to write down any questions you have and bring them to our office hour time so that I can make sure we are all ready for Friday. Good job. We're done for today. I'm going to get us closed out. See ya.